Today we will ask the question, how many bonds does an atom want to form? There are three important factors. First of all, we need 2 electrons for the formation of an electron pair connecting those 2 atoms. Secondly, how many free single electrons does an atom have to offer for the formation of bonds? And third, how big is the atom? The bigger the atom, the more place is around the atom for the formation of the bonds. Let us start with the most simple atom, the hydrogen atom. There we have 1 proton in the core, and this is then surrounded spherically by 1 electron. 2 hydrogen atoms will form a hydrogen molecule with 1 connecting electron pair. Then, in the periodic table, the next element is helium. Helium has 2 electrons in the surrounding sphere. This is energetically favored. The helium is satisfied with itself. It is a typical noble gas that doesn't want to react at all. Next period, lithium has 1 electron in the outer sphere and therefore is able to form a single bond, for instance, with hydrogen. The single bond is polarized. About electronegativity we had discussed in the preceding video. It's polarized and therefore we have an slightly negative polarization at that hydrogen. It's symbolized by a delta minus written here, and a positive polarization at the lithium. So beryllium has 2 electrons in the outer sphere, able to form 2 bonds, also polarized. This is important for something we will discuss later on. Boron, 3 electrons, 3 bonds. Carbon, 4 electrons in the outer sphere. 4 electrons in the outer sphere, therefore forming 4 bonds, for instance, to the methane molecule. And there we already have the maximum of bonds that can be formed around an element of the second period. Let's go to the nitrogen. 1 additional electron. That will cause that 1 electron pair is formed, and the 3 remaining electrons are able to form bonds, for instance, to this molecule ammonia. 1 electron in addition, then we are at the oxygen with 2 electron pairs, 2 remaining free electrons for bond formation. Water is an example for a resulting molecule. Fluorine, an additional electron pair, 3 electron pairs, 1 free electron, and therefore hydrogen fluoride is a typical molecule that is formed. And with neon we then have 4 electron pairs, the same situation as with helium. This doesn't want to react anymore. So, as I said, typically hydrogen is forming only 1 bond, but for instance, in the water molecule, there we have a polarization. Oxygen is far more electronegative, therefore the oxygen-hydrogen bond is polarized towards the oxygen. We have a slightly positive charge at the hydrogen, and this then can coordinate to a free electron pair of the next water molecule. Here a weak bond is formed, but as you see, overall this is more than a single bond at that hydrogen. Here in addition we have then a so-called hydrogen bridging bond. With beryllium and also with boron we can observe we have here a negatively polarized hydrogen, but a positive polarized central atom. This then can coordinate to the electron density of the next hydrogen molecule, and is forming such a chain also with hydrogens then bridging beryllium centers. The same is observed for this BH3 molecule, but this is then forming dimers with a molecular formula B2H6. And let us have a short look at the third period. Let's go to the element sulfur. Sulfur has a more than 30% larger diameter compared to carbon. There is more room around the sulfur, and therefore sulfur is able to form a molecule with 6 fluorine atoms. They have enough space around that sulfur, and this SF6 molecule is a rather stable molecule. Actually, it is a gas. Well, thanks for listening.